session. I didn't do that. All right, the goal is to isolate the x in the middle so that the final step has this.
The next step is going to be, by the way, negative 12 is less than 2x plus 8 is less than 18. Yeah, I know.
Okay.
It's like...
I don't have any problem at all with doing it that way. There's usually a few ways to do these. So there's
And then what we're
no
doing in
one
class...
correct answer. So you've eliminated...
What she's doing in class...
Okay.
What she's doing in class and wants us to do is separate the answers.
Okay, that's fine.
To separate the problem.
Okay. So she wants two problems? In other words, she wants one problem that's that and another problem that's this?
Yeah.
And solve each one of them separately?
Yeah.
Okay, that's fine. So we're down to 2x plus 8. So let's solve that one. What's the next step?
You're going to be subtracting 8 from both sides.
So what's the next line?
Negative 20 is less than 2x.
And the next line?
Is it going to be negative 10 is less than x?
Correct. So that solves this part. Now let's go to this part here, and I'll do that over on the right.
It's going to be minus 8 on both sides, and then it's going to be 2x is less than 10 divided by both sides by 2x is less than 5.
All right. So we got two answers. X is greater than minus 10 and less than 5. Do they have you at a
And then she wants us to
graphing them?
Yeah, she wants us to put them back together and then graph them.
Okay.
So it's going to be negative 10 is less than x, which is less than 5.
Okay.
And then graphing, it's going to be negative 10, 5, 0.
Open or close circle at negative 10?
It's going to be closed. And then it's going to go straight up to negative 5.
Open circles always go with these kind of inequalities.
Yeah, I said open.
Closed circles go with those kind of inequalities.
Yeah. And then they're going to be, they're both open, and it's going to be two open circles connected with a line.
Correct. In other words, x is anywhere in between those two numbers. And notice that we really did not have to separate these. We could have done it the way I was going to do it in the first place, where I would have ended up with that at the bottom. And just so you know how that is accomplished, let's go back a step. I want to show you this. Whether she teaches this or not, you should know it. In other words, when you have an inequality like this, I can treat it like a regular inequality that just has two sides to it. In other words, the first step I can do is subtract 8 from all three places. So that would give me minus 20. Now the 8's no longer in the middle, so there's just 2x. Well, when I subtract 8 from 18, I get 10. And now I can divide all three places by 2. So I get the same answer a lot quicker, really, and a lot easier. And now I don't have to worry about putting it back together again or anything. So I understand why she wants you to separate it and do it in two pieces originally, and then put it back together again, but you don't have to. Okay?
Okay.
You can do
but
it.
She likes us to do it.
That's fine. I never want to disagree with the teacher. However she wants you to do it, you can do it. But I am a big believer that You know what they say is the biggest difference between schools in Asia and schools in the United States?
What?
In the United States, we spend an hour studying 20 problems. In Asia, they spend an hour studying 5 problems, doing each one 4 different ways. And Asia outperforms the United States by a lot. So I'm kind of a big fan of taking a problem and doing it in multiple ways and looking at it from multiple angles and knowing everything there is to know about that problem. All right, what else you got? You got another one?
Yeah, I have a...
Don't just give me the ones you've already done.
No, the reason I did that was because I was doing the right side.
Okay.
Accidentally before you start doing the left side, so I just knew what it was.
Make my efforts as valuable to you as they can possibly be, Logan. And that's usually if you're gonna, you want to give me the problems that you're having difficulty with, not the ones you know how to do. So what's another one?
Okay. 22 is less than 4x minus 6, which is less than or equal to 38.
Okay. So we'll do this part first. What's the next line? I'll go down like this.
Okay. The next line is going to be 28. 28 is less than 4x.
And the next line?
And you divide both sides by 4, which is going to be 7.
Mm-hmm.
Cool. 7 is less than x.
Yeah, you're gonna be saying cool a lot because math is all about doing these single digit manipulations. So that's why I spend so much time on drilling you with those, is because they are so important. Next line on the right side.
4x is less than or equal to is 44.
Right. And see, what you're really doing there is adding 6 to 8, right?
Yeah.
In other words, I know you're adding 6 to 38, but what you're really doing in your mind is adding 6 to 8 and getting 14, carrying the 1, so that's how you get 44. But it's important to understand that that's not really 2 digits plus 1 digit. That's 1 digit plus 1 digit in terms of understanding it. And then what's x equal to? Or x is what?
X is less than or equal to 11.
Is it less than or equal, or is it just less than?
X is less than or equal to.
So up in the top, this one, they're both less than or equal?
Oh, yes.
Just the right part.
4x is, yeah, it's just the right part. Okay. I said that, but...
Okay, I didn't hear it. Okay, so we got x is greater than 7. And it's important to understand on the left here that if you're more comfortable with your variable on the left, now when you're dealing with equations, it really doesn't matter whether your variable ends up on the left or the right. But a lot of people, they don't like this. They don't like it when the variable ends up on the right in an inequality. So if I want to turn that around, means the same exact thing as that. Okay. Now, if we want to graph it,
it's going to be open circle for 7 and closed circle for 11, and they're both going to be interconnecting.
And you can see from that that x would be less than 11, greater than 7, so it would be in between those two numbers.
Uh-huh.
Not always.
Now we're working on
Not always
instead of doing.
Sometimes you get an answer that looks like this. In other words, that goes one way, and this goes another. Okay.
Yeah, that's actually what we're doing next.
Okay, cool.
It's the next thing that we're doing. We're using the term in school called OR. So for the ones that we've been doing and, like 22 is less than 4x, or yeah. Right. And now we're going to be using the term OR. Okay. But the graph is going to be the same graph. So now we have two things to do. Okay. So it's 2c plus 5 is less than or equal to negative 11. 2c plus 5 is less than or equal to negative 11.
Okay.
Subtract 5 from both sides. 2c is less than or equal to negative 16.
Okay.
Divided by 2.
You're doing all this without a calculator?
Yeah.
Okay, good.
C is less than or equal to negative 8, right?
Yes. Now let me ask you one question about the calculator. How much do they let you use a calculator in class and on tests?
In class, they let you use it, but it's unnecessary because a lot of things that we're doing, we don't need one. Okay. So we normally don't do it, but we have the resources, and they do let us use it on tests, okay. The calculator, okay. Because they have problems that would just unnecessarily stump us, like it's multiplying and dividing with fractions.
I understand when you need to use a calculator. In other words, if I asked you to multiply that number times this number here, I would not expect you to do that by hand. Even though you probably could, you'd use a calculator all.
It would take way longer.
Well, right, exactly. So you'd want to use a calculator for that. My only reason I asked is because go as long as you possibly can without using your calculator, only because that's going to force you to practice drill these single digit stuff.
The only time I normally use a calculator.
I have a girl student who's taking precalculus, and she has to use a calculator for all of these. She just does not know her times tables. And she's managed to get all the way to precalculus.
1 second.
But
okay, sorry.
She knows how to use her calculator really, really well. But I don't want you to get to a point where you have to be like her. In other words, she has to use a calculator to multiply a number by 10. She just is so totally dependent on her calculator because she never got perfect with her arithmetic. And if you're not perfect with it, after a while you do rely on the calculator because the calculator give you the correct answer, whereas if you depend on your brain, you're going to make, one mistake every 100 times or something. So it's a real easy thing to accidentally get into the habit of using the calculator, and then you never go back. In other words, once you use that calculator for these kind of problems, you're never going to do it in your head, and then you're going to forget how to do it in your head. And that's what happened to her. And I don't blame her. I don't blame any kid that is dependent on a calculator because that would be the natural evolution of things. Is the calculator always gives you the correct answer. Why would you not use it every single time? Well, there's a good reason why you shouldn't. But, all right, what's the rest of this problem? So that's one of them.
Then it's 3c minus 1 is greater than or equal to negative 7.
Next line.
We're going to be adding 1 on both sides.
You can just give me the line.
So it's going to be 3c is greater than negative 6.
Yeah, what I'm primarily is make sure you can do the math. I know you know what to do.
And then the next line after that is going to be c is greater than or equal to negative 2.
All right. Now, if we look at this on a number line, we notice that they're not going to connect.
Yeah, they're going to be going different
So
directions.
I have a -8 there. There's -2. And I got C is less than, closed circle, open circle, at -8.
They're both closed circles.
And which way does the line go from -8? Left or right?
Left.
And from -2?
Right.
Yeah, so there we have a segment. Have they taught you interval notation yet?
So I'm guessing because I don't know what that is, no.
Well, here's the way I would write this. You may get it soon, you may not. It goes from -infinity to -8 with a bracket, because it can be -8, in combination with a bracket -2 to positive infinity. And that is the way you would define that answer to most mathematicians, is it's two intervals. It's an interval that goes from -infinity to -8, and it's another interval, or -2 to positive infinity. And if they haven't taught you this yet, then we won't use it, but that's one way to give the answer. How do they want you? They want your answer to be in two statements. That's statement 1 and this is statement 2. Joined by
Yeah.
an or?
Yeah.
Okay. All right.
And we have 2p plus 1 is less than -7.
Next line.
2p is less than -8. P is less than -4.
You're getting faster, I can tell.
Then it's 3 minus 2p is less than or equal to -1.
Next line.
2p is less than or equal to -4.
Hold on,
and then,
hold on. That's not the next line. The next line is -2p. You cannot drop that negative sign. Just because you move the 3 over, that negative sign still is attached to that 2p. Okay, so it's -2p is less than or equal to -4. And now what's the final line here?
p is less than or equal to -2.
Okay. When you have an inequality and you divide or multiply either side by a negative sign, you have to turn this thing around and face it the other way. Okay?
Oh, yeah.
And you still have to divide both sides by -2. So what's -4 divided by -2?
-4 divided by -2. It's going to be -2.
-4 divided by negative.
I mean 2. Just 2.
A negative divided by a negative is a
just
positive. 2. So that's the answer. So, and this is a key difference with inequalities as opposed to equations. When you're doing equations, you don't have to worry about this. But when you're doing inequalities, and it's only when you divide or multiply by a negative number that you have to do it. It's not when you subtract or add. I could subtract as many p as I want from either side, and I don't have to switch the direction of that inequality sign. But if I'm dividing or multiplying, I do. Okay. Now, this, much like the last one, ends up having two answers.
It's going to be...
Or that.
Yeah, p.
Let me draw my number line.
Yeah.
Put the number 2 on there and put the number -4 on there. Notice that I don't worry about putting 0 on there. It's not really necessary.
Yeah.
Okay. And how do I draw the graph?
It's going to be a open dot on -4 going left and closed dot on -2 going right.
All right. Sounds like you have these down pretty good. What else you got?
We have to describe and correct the error. We have to describe and correct the error in solving the inequality or graphing the solution.
Okay.
So what I'm about to say, it's not me doing, it's they might be wrong.
That's fine.
4 is less than negative 2x plus 3 is less than 9.
Okay. What's their next step?
And then the next line they did was 4 is less than negative 2x is less than 6.
So they're solving it all in one thing. Okay.
Yeah. And then it's going to be negative 2 is greater than x is greater than negative 3.
Very good. Negative 2 is greater than x is greater than negative 3. Well, so
And their graph that they did
I don't see any mistakes. In other words, I had to change both sides because I was dividing this by negative 2, the middle part by negative 2, and the right part by negative 2. So
they have their graph right.
The mistake must be the graph. You say they have it right or they have it wrong?
It's negative 3 is going towards the right and negative 2 is going towards the left, both open circles.
So x is less than negative 2, yeah. And this is what they have?
Yeah.
And they say, tell the mistake?
Yeah.
Okay. Here's the mistake. This is a bit tricky, more than a bit tricky. Is this an and or an or problem?
This is a and.
Ah, see, that's the difference. If it was an or problem, they would have done it correctly. But here's what they're saying. X is greater than negative 3. So I can draw that one like that. And this part here says x is less than negative 2, right?
Yeah.
So I would draw it like this. And the solution is all real numbers. No, it isn't.
What's the mistake, though?
Well, hold on a minute. This is where the and and the or always gets confusing. And it depends on what they... In other words, if we look up here and we do it the normal way you would do it, you get this answer, and that answer is between negative 3 and negative 2, correct?
Yeah.
And if you plug in some numbers, in other words, the way I tried to tell you that it was all real numbers, we know that's not true because 100 doesn't work, right? Can x equal 100? Yeah. No. If x was 100, this would be negative 197, which is not between 4 and 9. So their answer is actually correct if that was the problem. Was it spelled out like that, or was it given to you as two statements?
It was spelled out like that. Let me look it over. 4 is less than negative 2x plus 3 is less than 9.
Yeah, no, according
to this... Should I take a picture of it?
Yeah, do take a picture of it and send it to me real quick here. I'm curious about this. because this might actually have wider implications on the difference between and or.
Mm-hmm.
Because there are some problems where the answer is all real numbers if it's an and problem or an or problem. I'm not positive. To be honest, I don't remember exactly the difference. So please do send it to me. I want to see what they show.
Well, ands, they're supposed to be going like that. Ands go into each other, ors go outwards.
Yeah, I don't think it's quite that simple, but let's have a look at your problem here so I can figure it out. There are some strange ones where...
Oh, I texted it to you.
Yeah, don't do that. Send it to my email. In other words,
Okay.
I can't bring it up on my computer if it's on my phone.
What's your email?
David Cowan, 1940. Here, let me write it. You haven't sent anything to me yet?
Never.
Okay. You'll only have to type it in completely once, and then it'll be in there.
Yeah.
Here's how you spell it. @gmail.com. Yeah, no, that's a good thing. Let's get out of the way. Have you send a picture to me, because then it'll be much easier the next time. See, if that was an and problem, it would have to be two statements. I think. I don't know. I want to look at it.
Okay.
Okay. Hold on. I may have to download this in order to be able to rotate it. Well, not rotating, but let me look at it. I can, oh, there it goes. Okay, hold on. Okay, we can see it now. So it was minus 2x plus 3, and then they got, oh, I see the immediate problem. When they subtracted 3 from the right side and the middle, they didn't subtract it from the
yeah.
left side.
Oh, yeah.
That's the only mistake. So this would be a 1. So it should be 1 is less than negative 2x is less than 6. And then it would be x is greater than minus 3 and less than minus 1/2.
Mm-hmm.
So the answer lies in the interval between minus 1/2, which is right here on the picture, and minus 3. So that's all. So this was not an and or question. This was an arithmetic question. All right. Hold on. Did I just miss that when we pulled it up the first time, or what? Let me see if I did. When we did this problem the first time, yeah, I did. I missed it totally. We subtracted 3 from the right, and I forgot to subtract 3 from the left. Inequalities are a lot like equations, even if you have 3 parts. Anything you do to the left part, you can do to the middle part, you can do to the right part. Okay? So it's like having an equation that has 3 pieces to it. And you always have to do the same thing to all three pieces. In other words, you can't subtract 3 from the 9 and not subtract it from the 4 or the middle. All right, what else?
The other one is way easier, the other one was way easier, the phi. They just got the graph wrong and the phi goes a different way.
All right, so you got it figured out? Can I see that other one? Did you include it on that picture?
No. Okay. No, but I can tell you it.
Do you need to, or you got it completely?
No, I have it.
Okay, well, let's not go there then. Go to the next one after.
Okay, I have 2 more questions, but this one is modeling with mathematics.
Modeling with math. Okay.
Mathematics. The interior temperature of an iceberg ranged from -20 degrees Celsius to -15 degrees Celsius. Write and solve a compound inequality that represents the possible temperatures in degrees Fahrenheit. And the conversion is C equals 5/9 and then parentheses F minus 32.
Okay. So to answer this is all we have to figure out is what is -20 Celsius in terms of Fahrenheit, right? And also what is -15 Celsius in terms of Fahrenheit. So how do we do that?
So we're going to be writing -15 degrees Celsius is less than C, which is less than -20 degrees. I mean, -20 degrees is less than C, which is less than -15.
Let me suggest a different way to do this.
I'm just doing it the way that we've been doing it in school.
Truly?
This is how she taught us to do it. But okay, I'll do your way.
Well, I'm not even sure I understand her way.
Well, it's really simple, and you just have to have seen the problem.
I tell you what, on the basis of what I said about the way they teach in Asia, let's do it my way, and then we'll talk about how she did it in your way. There's absolutely nothing wrong with trying 2 different ways. Okay? The way I would do it is I know my temperature is less than, or it's, excuse me, if I call my temperature X, I know that it is greater than -20 and less than -15, correct?
Yeah.
Okay. Is all I have to do is convert that to a Fahrenheit and that to a Fahrenheit, and I'll have my answer.
Yeah.
However, to convert it, well, C is what's -15. In other words, when you write this equation here, that means that the temperature in Celsius is equal to 5/9 times the temperature in Fahrenheit minus 32. So
yeah,
I can substitute, what happened there? I can substitute -15 for the C and then solve for F to get this temperature. Okay? Well, how do I do that?
Yeah.
You're going to have to do some variation, regardless of how she did it. She's going to have to go through this step at some point.
This is actually what she was doing.
Okay, good. I might have just misunderstood you. So how do you solve for F? In other words, we need the equivalent temperature in Fahrenheit that is -15 degrees Celsius, which means you have to solve this equation.
So we're going to be doing in your way, -15 is greater than
We can even
5/9 and then parentheses f minus 32.
We
Negative.
can leave it equal for now, just to make it more understandable. In other words, is all I'm going to do is I'm going to solve that for f, and then whatever number I get for f is what I'm going to put in here for minus 15. And then I'm going to do the same thing for minus 20, solve it for the f that corresponds to minus 20, and stick it in for there. So I don't even have to look at this as an inequality problem. You'll see. Leave it as an
Actually, this is exactly what she's doing.
Okay, good. So the only difficulty...
This is exactly what she's doing. She just added a step in it. She just added a step into it that you didn't do. Because you are doing what you're doing.
What is the equivalent Fahrenheit temperature that agrees with minus 15 degrees Celsius? And to get that, you have to solve this equation. What's the first step in solving this?
We're going to do the 5/9 times f times negative 32.
You know, that's not the best way to do it. And I'll tell you why. It's because when you do the 5/9 times the 32, you might end up with a fraction.
Okay.
And you don't want to end up with fractions if you can avoid it. And in fact, the first best step for solving this is to get rid of that fraction. How can I get rid of the 5/9 the quickest possible way?
By multiplying both sides with it.
By what? By 5/9 or by 9/5?
Yeah. 9/5.
Always by the reciprocal. I'm going to multiply the right side by 9/5 and the left side by 9/5. And that, on the right side, immediately gets rid of that and leaves a very simple f minus 32. And what's it leave on the left side? How do you multiply 9/5 times minus 15? Do you multiply the 9 by the 15, or do you try to reduce it first?
I don't know.
Always try to reduce. Notice that if I multiply 9 times 15, I get 135 that I would then have to divide by 5. That's a lot of math. I'm going to need a calculator. Right?
Yeah.
But if I reduce first by dividing top and bottom by 5, well, that goes to 1, and that goes to minus 3. Now, as all I'm doing is multiplying 9 times minus 3, there's my answer to the left side. And I never had to deal with a number greater than 27. I certainly didn't have to deal with any 3-digit numbers. So you always reduce, always. Now this becomes relatively simple. So what's f equal to?
And then f is equal to... one second.
It's 32 minus 27.
5.
Okay.
Right?
Yeah. That's the first f. That's the f that corresponds with the 15 degree, the minus 15 degrees Celsius. Okay? Now let's solve for the other f. Well, we still have this equation. This equation is always true. That is the relationship between Celsius and Fahrenheit. Okay? Only this time, it's not minus 15, it's minus 20, right?
Yeah.
Okay, I'm still going to leave it as an equation because all I'm attempting to do here is figure out what the equivalent Fahrenheit temperature is that agrees with these Celsius temperatures. Well, again, my best first step is to multiply by 9/5. So I'm going to multiply by 9/5 that side and by this side by 9/5. How do I do this?
You're going to reduce the left side.
To what?
Because it's going to equal, you're going to reduce
I
it
have to
to
divide top and bottom by. That's the way to think of it.
20 divided by 5 and then multiplying by 10, right?
No, you're just going to divide the top by 5 and the bottom by 5. In other words, here's what I'm looking at. Here's what I'm looking at. Right?
Uh-huh.
If I divide the bottom by 5 and the top by 5, I've merely multiplied this whole thing by 1 or divided it by 1, however you want to look at it. And I can take any fraction and multiply or divide it by 1 without changing it. So that's what you're doing when you are simplifying, is I'm dividing the bottom by 5, leaving 1, and I'm dividing the top by 5, leaving minus 4. Now it's real simple. 9 times minus 4 is minus 36 equals F minus 32. Add 32 to both sides, and you get this F.
2.
4, minus 4.
Oh.
So F, in other words, minus 20 degrees Celsius is the same as minus 4 degrees Fahrenheit. Minus 15 degrees Celsius is the same as 5 degrees Fahrenheit.
Now we have to write it as an compound inequality. So is it going to be?
I can see that on the one side is my lower temperature, minus 4, and on the other side has to be my higher temperature, which is 5. So
5.
In Fahrenheit, that's the range. In other words, this temperature has to be between minus 4 degrees Fahrenheit and 5 degrees Fahrenheit. That's the same as being between minus 20 Celsius and minus 15 Celsius. And there's really only one way to do this. You know it's in between. The problem stated that, right? That it was greater than minus 20 and less than minus 15?
Yeah.
Yeah. So all we need to do is substitute those Celsius temperatures for Fahrenheit temperatures. And there's no real reason to confuse anything by using inequalities when we're doing it. In other words, I used an equation there and an equation there, and then when I got to my final answer, I turned it back into inequalities, because all I was really looking to do was to replace the centigrade temperature.
Okay.
In other words, up here, that says I'm greater than minus 20, less than minus 15. Well, if I know what these Fahrenheit temperatures are, that's all I need to do. And the minus 15 is 5, and the minus 20 was minus 4, so I end up with that, which is the same as I wrote, even though it looks a little different. Notice that I did it, I put the minus 4 on the left and the 5 on the right, and I reversed the signs, but this is the same as what I have circled here. That's exactly the same. This line right here is...
Do we have time for one more question?
Yeah. Go ahead.
Okay. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. Use the triangle shown to write and solve three equalities. Your friend claims that the value of x can be 1. Is your friend correct? Explain. The triangle is 7 on the right side. On the left side. X on the right side and 5 on the bottom. It's x. Yeah.
Okay. So the statement you gave me is one that you should remember, because it's vital in geometry. When you get to geometry, you'll need that. That any side of a triangle has to be less than the sum of the other two sides and greater than the difference. That's what that theorem says. Well, if I want to write that out, then I would say x has to be less than the sum of the other two sides, which is that, and it also has to be greater than the difference of the other two sides, which is that. So what I end up with is x has to be less than 12 or greater than 2. That's the only, in other words, less than 12 and greater than 2. So x has to be in between these 2 points for that to be a triangle. In other words, if x was 13, it would not be a triangle. It couldn't be a triangle.
Okay.
Okay, and in fact, x cannot even be 12. This is not a less than or equal to. This is a less than. The theorem says any side of a triangle has to be less than the sum of the other two sides, and the rest of the theorem is just the reverse. When I say the reverse, if it's less than the sum of the other two sides, the reverse of that is greater than the difference of the other two sides. So you really only have to memorize the first part of it and know that the second part is just the reverse of it.
Okay.
Okay, and that, in other words, you'll get, in geometry, you'll get problems like, tell me if this could be a triangle with these 3 sides. Can you make a triangle with those 3 sides?
I don't know.
You cannot.
5
has to be less than the sum of 2 plus 3. And it isn't. It's equal to it. However, you could make a triangle with these 3 sides. So that theorem applies to every single side of the triangle. Notice in the first triangle, not only is 5 not less than 5, but 2 is not greater than 2, and 3 is not greater than 3. So there isn't a single side of this triangle that fits both parts of that theorem. So,
okay.
And that's also not a triangle. You cannot have that triangle because 6 is not less than 2 plus 3. And one last one. I'm focusing on this because this is actually pretty good. Can you have this triangle here?
Yes.
Correct. Notice that every side follows the theorem, right? In other words, if I start there, 10 is less than 12, and 10 is also greater than 8, so that one works. This one over here, 10 is less than 12, 10 is greater than 8, that one works. And 2 is less than 20 and greater than 0, so that one works. And what would this triangle look like? Maybe like this. 10, 10, and 2. So you have to be a little careful when you're applying that theorem. In other words, this can be a triangle, and yet 2, 3, 5 cannot. And most people, if they were guessing, they would say, well, that looks like a triangle, and that does not. You know what I'm saying?
Yeah.
So you kind of have to apply the theorem to every single side of the triangle to figure out whether you can actually have a triangle like that. All right, that's a good place to stop. Logan, that was a good session. I will talk to you at 5 o'clock next week.
Okay.
All right, have a good week.